Good morning, students. Today we are going to discuss the energy stored in an inductor and LC oscillations. So, do you know what is meant by inductor? Inductor means it is a solenoid, and solenoid stores energy in the form of magnetic potential energy. So, energy stored in the inductor is magnetic potential energy. We already know energy equal to work. So, I can define energy like this. It is the work done in growing the current in an inductor from 0 to a maximum value I. I repeat, it is the work done in growing the current in an inductor from 0 to a maximum value I. So, let us first write like this: induced EMF. Induced EMF E is equal to L into di by dt. This is the expression for the EMF, right? And since the EMF opposes the cause, I put a negative sign here. Now, work done in a small time dt. For a small time dt, I will write the work as dw, which is P into dt. Work is power into time, P into dt. Now, what is power? Voltage into current. So, minus EI dt. Because power has to be expended against the back EMF to grow the current. Okay? The back EMF induced in the inductor opposes the growth of the current. So, work has to be done against the back EMF. That is why I put here negative sign. Now, we will put this value. Instead of E, I can put this value here. So, dW will be minus of minus L di by dt into dt. So, minus of minus becomes plus, and you can cancel dt and dt. Therefore, you will get dw is equal to L I di. So, here there is an I remaining into I into dt. So, Li di. This is the small work done. Now, how will you find the total work done? Total work is integrating. Okay, so let us integrate. Total work. W is equal to L is constant, so I take L outside. Integral I di. And I told you, you have to grow the current from 0 to maximum. So, I will get W is equal to L into, what is integral I di? Yes, I square by 2. This work done is stored as magnetic potential energy. Therefore, we can write magnetic potential energy. Magnetic potential energy, it is written as U subscript B. U for energy and B for magnetic. So, magnetic potential energy UB is equal to half Li square. So, UB is equal to half Li square. This is the expression for the energy stored. Now, I will tell you, you can express this energy in terms of magnetic field B and area A. And after that, we can find the energy density also. So, this is the expression for the energy. Now, we are going to energy density. So, let us see. In chapter 6, we have studied L is equal to mu 0 n square A by L. This is the equation for the self-inductance. And we also know B is equal to mu 0 n by L into I. So from here, what is I? I is equal to BL by mu 0 n. Am I correct? BL by mu 0 n. So substitute these two quantities in the above equation for UB. So UB becomes half mu 0 n square A by L into B square L square by mu 0 square n square. So like terms can be cancelled. So I am just cancelling the like terms. One L and this L square gone. This mu 0 and mu 0 square gone. Then n square and n square is gone. So what is the remaining thing? Remaining thing is UB is equal to half B square by mu 0 into AL. So this is the expression for the energy in terms of B, A and L. Now let us see what is energy density. So I can write like this: energy density is equal to energy by volume. Energy density is energy by volume. So I will write UB is equal to capital UB by volume can be written as area into length. And what is UB? Half B square by mu 0 into AL. That divided by AL. So AL and AL can be cancelled and you will get the final equation as UB is equal to B square by 2 mu 0. This is the expression for the energy density. So this is the above one is the expression for the energy and this one is the expression for energy density. Okay, so from this equation you can say that energy density is directly proportional to B square. In chapter 2 you have studied electric energy density. In chapter 2 you have studied electric energy density, that I have written as UE, and that is half epsilon 0 E square. So you just compare these two equations. Here mu 0 is coming in the denominator but epsilon 0 in this equation is coming in the numerator. And you can see energy density, electrostatic energy density is UE, which is directly proportional to the square of the electric field. Magnetic energy density is directly proportional to the square of the magnetic field. Okay, so that's all about energy and energy density. Now we are going to study LC oscillations. L for inductor, C for capacitor. So LC oscillations means there is a circuit comprises of an inductor and a capacitor. DC will first flow from capacitor to inductor and then it flows back from inductor to capacitor. So if I give DC in a circuit like this, DC will be converted into AC. So LC oscillation means, LC oscillator means it is a device which is used to convert DC to AC. And it consists, the circuit consists of two devices, a capacitor and an inductor. This circuit is called tank circuit. Tank means energy storing. So this circuit is called tank circuit. So let us see how the LC oscillations are taking place when I give DC. So initially I have charged the capacitor to a maximum value. So I am writing like this: the energy stored in the capacitor is maximum, and at the time t is equal to 0, energy stored in the inductor is minimum. Okay. So in the first figure, energy stored in the capacitor is maximum and energy stored in the inductor is 0. Now, since the capacitor is fully charged, current will flow through the capacitor towards the inductor. Look at the second figure. At a time t by h, that means 1 by 8th of the time period. So at any instant of time, the energy in the capacitor decreases, and that energy is moving towards the inductor. So the current will flow from capacitor to inductor and magnetic energy will be generated across the inductor. Now after some more time, the entire capacitor, the entire energy of the capacitor is transferred to the inductor. So you just see that now the capacitor is empty. Look at the third figure. In the third figure, you can see that the capacitor is now empty and the energy stored in the inductor is maximum. Okay, now what will happen? At this point of time, what will happen? Now there is no more energy, no more electrical energy for the capacitor to get it discharged to the inductor. Meaning, capacitor cannot produce any further energy. So what will happen? Current in the circuit will decrease. And when the current decreases, there is a change in the magnetic flux, due to which induced current will be formed in the inductor. That induced current will try to oppose the decay of the current in the circuit. What I mean is, due to the decrease in flux, an induced current will be formed in the inductor that will maintain the current in the same direction, which means the current produced by the inductor will flow through the capacitor and charge the bottom plate of the capacitor positive, thereby creating a negative charge on the upper plate. So look at the fourth figure. In the fourth figure, you can see the capacitor is getting charged with opposite polarity. That means the bottom plate is positive and the top plate is negative. Initially, the upper plate was negative and the lower plate was, initially the upper plate was positive and the lower plate was negative. But now the upper plate is negative and the lower plate is positive. Now look at the next figure, fifth figure. In the fifth figure, you can see that the energy of the inductor is getting transferred to the capacitor, and finally the capacitor gets fully charged, the inductor charge is 0. So the energy stored in the inductor is now 0 and energy stored in the capacitor is now maximum. At this stage, what will happen? At this stage, inductor cannot provide any energy further. Energy in the inductor is 0 and the capacitor is fully charged. Now what happens is, current will start flowing in the opposite direction. That means the current will start flowing from the capacitor to the inductor in the clockwise direction. Initially it was in the anti-clockwise direction, but now it is flowing in the clockwise direction. So remember, the direction of the current changed at this moment. So it flows through the inductor, and you can see in the next figure, sixth figure, that the energy of the capacitor is getting transferred to the inductor. And after some time, what will happen? Look at the next figure. After some time, the capacitor is empty, the inductor is having maximum energy. Then, due to the change in flux, induced current will be formed, and that induced current will flow in this direction, which charges the upper plate of the capacitor positive and lower plate of the capacitor negative. And look at the last figure. Inductor is having the charge 0, energy 0, whereas the capacitor having maximum energy. The circuit has come to the initial state. That means the last figure is same as that of the first figure. Look here. Last figure is same as that of the first figure. That means the system has come to the initial state. Now the system will run like this continuously. So this is called one time period and one oscillation has taken place. Like that, many oscillations will take place and you will be getting alternating current. So this is how an LC oscillator works. I hope you have understood this. And I have to say one more thing. Here we have told the ideal condition. That means the oscillations produced, the current produced will have no damping, which means the amplitude is constant. Such kind of oscillations are called undamped oscillations. Look at this, undamped oscillations. Whereas in the real practice, there is an energy wastage in the capacitor in the form of heat. Energy can be wasted in the inductor due to flux leakage. So the actual oscillations, in the actual case, the energy will be reduced. So the amplitude of the oscillation decreases, which I have shown in the second graph, and this is called damped oscillations. So damped oscillations means the amplitude decreases. Okay? Yes. Now look at this. How will I get the angular frequency of oscillation? Angular frequency of oscillation is given as omega is equal to 1 by root LC. And the frequency of the LC oscillation, which is F, that is omega by 2 pi. So I can write 1 by 2 pi into root of LC. This is the expression for the frequency of oscillation. So that's all about LC oscillations. Thank you.